focusing on the year one students who are getting prepared for their exam. Basically, examination is what it is. Let me use that word. Anyone that wants to write exam, the examination comes with its phobia. It does not respect any status. Even if a professor wants to write an examination, he will feel it. When you have confidence, a few hours or few minutes to the exam, you will know that okay, what you're preparing for is almost there. Okay, so but the major thing about examination is preparations, and you don't go into an examination hall without a clear-cut plan what you want to do. So every examination has its own pattern. In most cases, especially for national diploma, you want to write examination for 2 unit courses. It comes with 6 questions, answer 4. Or for 3 unit courses, it comes with 7 questions, answer 5, as the case may be. So you already know what the exam looks like. The next thing is, what do I want to do in the examination board? One, if the questions are topic wise, like question 1 deals with so topic, or a topic takes care of 2 3 questions, then you will know which area you should focus more on. So for this and the one course, it cut across several many faculties. About 3 or 4 faculties are offering the course, so we will generalize our focus. I find this particular question 1 very interesting because I discovered that across the faculties, several departments, this question keeps coming up every session. So I'll be taking that question now. Question 1. Question 1 says that simplify the following. Question 1A. Simplify the following. 1. 4 into 2 raised to power n plus 1 minus 2 raised to power n plus 2. Everything divided by 2 raised to power n plus 1 minus 2 raised to power n. 2. 5 multiplied by 4 raised to power 3n plus 1 minus 20 multiplied by 8 raised to power 2n. B. This is question 1A and this is 1B. 1B says solve for x if 1. 9 raised to power x minus 4 multiplied by 3 raised to power x plus 3 is equals to 0. 2. Log x squared minus 2 base 2 is equals to log x minus 1 base 2 plus 1. We want to look into this question 1. Like I said, it keeps coming back, it keeps repeating itself. This one, this one in particular, and something like this, it keeps coming every session. So that draws my attention, and I like to look at this one by one. For the first one now, we have 4 into 2 raised to power n plus 1 minus 2n plus 2 over 2 raised to power n plus 1 minus 2 raised to power n. When we look at this, what do we do? It's very straightforward. Okay? We have this one has n plus 1 as the power, n plus 2 here, n plus 1. And so we have n in all the exponents. So we want to explore that one. For this, we have 2 raised to power n is common to all of them. Besides, I can rewrite this 2 raised to power n plus 1 as 2 raised to power n multiplied by 2, or 2 raised to power 1, as the case may be. And for these two, we will do the same. For these two, we will do the same. Therefore, in that case, so we have 4 multiplied by 2 raised to power n, 2 raised to power 1, or 2, minus 2 raised to power n, 2 raised to power 2. All of this divided by 2 raised to power n multiplied by 2 minus 2 raised to power n. Now we can see that 2 raised to power n is common. So we factor 2 raised to power n, and we are left with 4 times 2 here, minus 2 raised to power 2 here. Everything divided by 2 raised to power n. We are left with 2 here, and we are left with 1 here. And this will give us 2 raised to power n will go. We are left with 2. This will be 8 minus 4. 4 divided by 2 minus 1. So our answer is 4. So that is very straightforward. We go to the next question, Roman figure 2. For the next, we have 5 multiplied by 4 raised to power 3n plus 1 minus 20 multiplied by 8 raised to power 2. Also here we will be exploring the power because we have n at both ends. And in this case, okay, if we look at the base as well, we have 4 here, we have 8 here. The ones carrying exponent of 3n here, 3n plus 1, this one is carrying 2 raised to power n. So for this 2, for this 4, we can make their bases look alike so that we can easily perform operation. For this, we can have 5 times 2 raised to power 2 raised to power 3n plus 1 minus 20 times, this one will also be 2 raised to power 3. All of it raised to power 2n. And now, from here, we have, this becomes 5 times 2 raised to power, we are opening this one now, we have 6n plus 2 minus 20 times 2 raised to power 3 by 2, that will also be 6n. And therefore, this will give us, now we have 2 here, we can rewrite this one like the way we treated the first question, the Roman figure 1 there, where we have 2 raised to power n plus 1. This one is also the same thing as 5 times 2 raised to power 2 times 2 raised to power 6n. Why are we doing this? Because this one will give us 4. By the time we multiply by this, we'll be having about 20 minus 20 times 2 raised to power 6n. Besides, now have 2 raised to power 6n here, 2 raised to power 6n here. So we have to separate this using the first law of indices. Now, 2 raised to power 2 will give us 4. By 5, we have 20. 20 multiplied by 2 raised to power 6n minus 20 multiplied by 2 raised to power 6n, which is now 0. That's what we want to achieve. We have answered the question like that. Now, question, okay, I think I have the question here. B. One thing I have forgotten to do here is to distribute the mark. To every step that we take, we are expecting that we will be graded. So when you already know what you gain by every single thing you are putting down, then it will boost your confidence. Okay, so I'll do that for this now. We have a B, Roman figure 1 now. That one says we should solve for x. If 9 raised to power x multiplied by 4 times 3 raised to power x plus 3 equals to 0. If someone is seeing this for the first time in exam hall, it will take you some time to say, okay, what do I do? How do I digest this bet? One of the things about the examination is you have to get yourself prepared. You can't be seeing your question for the first time. Even if you have not seen that particular question exactly, you must have seen something related, something similar that will not daze you during the exam. Now, for this, we have 9. We have a 3 here, another one 3 here. So when we have common bases, we can easily do something about their powers. So I'm looking at this. 9 can be written as 3 raised to power 2, all this raised to power x, minus 4 times 3 raised to power x plus 3 equals to 0. I'm having 3. This one, there is a multiplication here. You can as well use dot if we like, as the case may be. So this will give us 3 raised to power 2x minus 4 by 3. I can decide to multiply it out. Okay, and we can still leave it because of the next operation we want to perform. Plus 3 equals to 0. You know, this look quadratic already. Okay, if I want to make an assumption now, let's 3 raised to power x be equals to y. You know, it follows that this equation now, let's call it star. Star. Equation star becomes, it becomes y squared now minus 4y plus 3 equals to 0. This is quadratic already, so I want to find the values of y, and in the end I'll come back to this and substitute to get the variable x that is our primary target. Now, from here we want to find 2 factors of minus 4, such that when we have minus 4, when we multiply we have 3. So if we use 3 and 1 itself, minus 1 minus 3 will give us minus 4, and when we multiply that one we have 3. Therefore we substitute that one in place of minus 4 now. So this will be minus y minus 3y plus 3 equals to 0. Now we factor y here, we have y left minus 1. We factor minus 3 here, we have y left minus 1 equals to 0. And definitely this will give us, I think I can remove this now. Into this. So we can see that y minus 1 is common now. We factor that y minus 1, we're left with y here, and here we're left with minus 3. Everything equals to 0. When two things a b multiply itself, we have 0. It either a is 0 or b is 0. Therefore y minus 1 is equals to 0, or y minus 3 is equals to 0. Therefore y is 1 or 3. Now remember, we make an assumption earlier that we should represent our 3 raised to power x with y. So we are coming back there now to do that. Since we know that, or you say recall that 3 raised to power x is equals to y. Therefore, when y is 1, we have 3 raised to power x equals to 1. We can write 1 in another form. 3 raised to power 0 will definitely give us 1. So we are writing that as 3 raised to power 0. So that x here down will give us 0. The only reason we are putting 1 in form of 3 raised to power 0 is because of this base here. So that we can have, once we have common base, we can equate their powers. Okay? And we know that anything raised to power 0 will give us 1. Okay? And the second now, at y, when y is 3, therefore 3 raised to power x will give us 3 raised to power 1. This implies that our x is equals to 1. Therefore, the values of our x will be 0 and 1. And now we want to go to the final question here. This B2. You can see the way the question is structured now. Just 2 simple questions for A, another 2 simple questions for B. You know, so we have a log x squared minus 2 base 2 equals to log x minus 1 base 2 plus 1. That's the question. So, to solve this, we have this one has log base 2, we can bring that together. Solution. I think in the past I have a lecturer whom if you don't write solution, you will not assume that you have started solving the problem. So I got used to that. So we have x squared minus 2 minus log x minus 1 base 2 now equal to 1. Because of the basis, common basis, we can perform operation here using one of the laws of logarithm. But here we have minus, and minus means division. Therefore, this will be log x squared minus 2 over x minus 1. All of this to base 2 equals to 1. But because if I leave this one as a constant, it will be difficult for us moving forward. So I want Mr. 1 here to look like this group here on the left hand side. What do? I multiply that one by log 2 base 2. Log 2 base 2 is 1. Okay, so I'm just writing 1 in another form. If we have another figure there, we'll be if this is 3, we'll be multiplying it by 3. But now this is 1, so we have multiplied by log 2 base 2. And now if I divide both sides by log 2, this will go, and we are left with x squared minus 2 over x minus 1 equals to 2. Therefore, we can easily perform operation now after we have cleared all the log functions there. Now we have 2 multiplied by x minus 1. When we cross multiply, we have that. And now, if I open this, I have x squared minus 2 equals to 2x minus 2. And we can collect like terms now. This looks quadratic already. So we have x squared minus 2x. When 2 is coming in here, it becomes a plus. So minus 2 plus 2 will give us 0. All of this will be equals to 0. I can factorize this one now and see what we have. Since it is quadratic, we have two solutions. Let's take it this way. X squared minus 2x equals to 0. If I factor x here, we have this. We are left with x minus 2 equals to 0. So it's either x is equals to 0 or x is equals to 2. This is the correct answer. Okay. So by so doing, we have answered the whole of question 1. And if you are in the polytechnic and you are to solve, you have solved this problem, you have earned yourself 15 marks. Because the question does not specify that, it does not compulsory any question, just say attempt any 4 questions out of 6. So if you are attempting any 4 questions out of 6, the total mark is 60. So 4 times 15, that means each question carries 15 marks. By answering the whole of question 1, as simple as it is, you already have 15 marks. And for each, let's take this one for example. How many steps do we have all together? We have this. Okay? We have this. Now, we have this. And if you are able to factorize this one successfully and you have the answer, that's another step that you have taken. So you get mark for this. You get for this. You get for this. And for factorizing and getting your answer, you get for this. If the whole of those are 15 questions, and we have had about, I think, four simple questions altogether, that implies this will be taking nothing less than 4 marks. So for each of these that you have answered correctly, 1 mark each. The highest thing another examiner can take is breaking this 1 mark down to half for this half for this half. Okay? For this half, for getting this one also half. For this half, for getting this one also half. And the answer 1. So any which way, just get your steps right and you will not lose any mark. Okay? And do not always assume that the examiner will think along your own direction. Whatever thing you think, put it. If you skip anything and you assume that the examiner will assume that no, this is what he skipped, this is what he meant to write. There's nothing like this is what he meant to write. What matters is what you have put in down. because this one is not an oral exam. You are writing. In fact, part of preparation is for you to sync your brain with your hand, such that when your hand think x squared, your hand is not writing x. When your head thinks cos y, your hand is not writing cos x. Okay, so those are the little things we need to take note of. So I'm going to question 2 now. Question 2 here, I have about 3 or 4 years question here. Okay, question 2 here from one of the department, I don't want to mention the name of the department. We have resolve the following into partial fraction. This one is combining partial fraction and solve. In B there, we have rationalize, so. For question 2 here, this one is testing quadratic. Okay, the question says, given ax squared plus bx plus c equals to 0, which is a general form of quadratic equation, show that the roots are x equals to minus b plus root b squared minus 4ac over 2a, or x equals to minus b minus root b squared minus 4ac over 2a. Hence, find the roots of 4x squared plus 8x equals to 5, which is straightforward, that one is testing quadratic. So given this equals to 0, question 2a in that case, okay, it says we should prove the quadratic formula. That is, we should prove that x is equals to minus b plus or minus root b squared minus 4ac over 2a. The question splits it into 2, splitting the addition from the subtraction. I'm generalizing it here. When we get to the solution, we'll separate it. Okay? So from here, what's the first thing we should do using the notion of completing the square method? We have to first reduce the coefficient of x squared to 1. So we now have x squared plus b over ax. I can bring this guy to the other side, minus c over a. Okay, that's step 1. Step 2, we want to take the average of the coefficient of x such that we now have b over a divided by 2. This will give us b over 2a. And for b over 2a, this result, the step 3 now, the third step is now that we square this result. Squaring this result. But the next thing we want to do now is to add this result to both sides of, let me name this equation 1, so that our work can be neat and we can easily make reference. Adding the result of this to both sides of equation 1 makes equation 1 changes to x squared plus b over ax plus b over 2a all squared equals to minus c over a. I want to change this one, it's fading out. Minus c over a plus b over 2a all squared. I've added that to both sides of the equation. And now, this one will give us, from here, by binomial expansion, we know, certainly, no doubt, that if we pick this first variable and the last, and we square them, their sum, by the time we expand, we come back to this. So I wouldn't want to waste much time on that and just go straight to the point, having this b over 2a all squared. This will now be equal to, I can rewrite this one also, bring this one first and repeating this one after. So I have b squared over, if I square this, I now have 4a squared minus c over a. When you are squaring this, it will become 2 squared a squared. And 2 squared a squared now will be 4a squared. Like we have it here. I can collect, I can take the LCM as 4a squared. 4a squared here we have 1 by b squared, we have b squared minus a here, that will be 4a by c, we have 4ac. All this one equal to x plus b over 2a whole square. And I am going to x anyway. So everything around x, I'll be reducing it until I get to x. I have to first take care of this square by taking the square root of both sides. The square root of both, finding the square root of both sides gives x plus b over 2a. If you take care of this, because it implies that multiplying that power by half. That's the meaning. So we now have plus or minus root b squared minus 4ac over 4a squared. From our solve, we can rewrite this one as root. We separate them. B squared minus 4ac over root 4a squared. And we know that 4a squared, okay, root b squared minus 4ac now divided by the square root of 4 will be 2, the square root of a squared will be a. So we have this, we have all of this equals to this. And now we are moving closer now. Because it is x that we want to get. We can go straight now. Now we have x equals to minus b over 2a. When that one crosses the equation sign, it changes sign. Okay? Plus or minus root b squared minus 4ac over 2a. And from here we can also take the LCM, and we have, I think I can remove this. And we have now x equals to minus b. Okay, sorry, I want to take the LCM from there. The LCM will be 2a. 2a in 2a, that will be 1. By minus b, I have minus b. Plus or minus 2a, that will be 1. By that, we have root b squared minus 4ac, which is what we want to prove. But the question specifies that we should show that x is minus b plus root b squared minus 4ac over 2a, or minus b minus root b squared minus 4ac over 2a. We have answered the first part of that question. And the second part is that we should, he said, hence find the roots of 4x squared plus 8x. 4x squared plus 8x equals to 5. So from here, we are covered. We don't have to start using, some people will now, this is where people tend to waste their time. They burn away their time. How? Already we know that we have used the completing the square method to prove this formula. You have to be smart passing an exam as well. It's very important. So in this case now, all we needed to do is make use of the formula. You know, when we compare this one to the given general form of quadratic equation, I think I can write this guy as 4x squared plus 8x minus 5 equals to 0. I've not done anything here. I've not changed anything. It's just the same with this. Okay, so by the time we compare this with ax squared plus bx plus c equals to 0, we discover that our a here will be 4, our b will be 8, and our c will be minus 5. Okay, a is equals to 4, b is 8, and c is minus 5. So we substitute all those into this formula now. We have x equals to minus b minus 8 plus or minus root 8 squared minus 4 multiplied by what is our a? 4, and our c minus 5. All of this divided by 2 multiplied by 4. Our problem is solved. Minus 8 plus or minus root 8 squared should be 64, if I'm not mistaken. This should be 64 minus 4 by 4, 16. 16 by, okay, let's say 4 by 5 minus by minus, we have plus. It should be plus. 5 by 4, 20, 20 by 4, we 8. I hope I'm not making any mistake here. Over 2 by 4, that will be 8. So minus 8 plus or minus, this one will be 144. 144 over 8. And with 144 should be 12. So we have minus 8 plus or minus 12 over 8. Here, the two answers required will be x equals to minus 8 plus 12 over 8, or minus 8 minus 12 over 8. If we remove 8 from 12 here, we have 4. And that will give us therefore x9 is equals to, that will be 4 over 8, or minus 8 minus 12, that will be minus 20 over 8. And this will be half, or minus 5 over 4. Sorry, minus 5 over 2. This will be the required solution for that question. And by so doing, we have finished 2A. And 2B here says, if the root of the equation 2x squared plus 3x plus 4 equals to 0 are alpha and beta, find the values of, if the solutions are alpha and beta, find the values of 1 alpha squared plus beta squared, 2 1 over alpha plus 1 over beta, 1 over alpha plus 1 over beta, and then 3 1 plus alpha, 1 plus alpha multiplied by 1 plus beta. I think that's all. So here, what do we need to do? This one is talking about the relationship between the quadratic equation, the sum and product, about the coefficient of quadratic equation and their sum and product. So we want to put our alpha and beta, we will first relate it to this equation, after which we have to put all of this in form of the sum of roots alpha plus beta and product of root alpha beta. This are the steps we want to take solving this problem. So from here, if we compare this one to the general form of a quadratic equation, we know that our A is 2, B is 3, and C is 4. But from our sum and product of roots, we know that sum of roots alpha plus beta is equals to minus B over A. Because of our time, I need to go straight to this. You know, in one of our classes, we have had this. We can refer back to them. And the product of roots, that is alpha beta, that one is equals to C over A. Therefore, alpha plus beta, the sum of root, is equals to minus 3 over 2. And alpha beta, which is the product of root, that one is 4 over 2, which is 2. Therefore, we want to take this one now one by one. Alpha squared plus beta squared, this is equals to alpha plus beta all square minus 2 alpha beta. This one is not far away. I think we got this one by, if let me quickly, just for the sake of this, if we have alpha plus beta all square, this one is a simple expansion. We got this one, this value from here. Alpha plus beta all square is saying alpha plus beta multiplying itself. Alpha plus beta. Alpha by alpha, we have alpha square. Alpha by beta, we have alpha beta. Beta by alpha, we have alpha beta. And beta by beta, we have beta square. And therefore, this gives us alpha square plus beta square. Alpha beta plus alpha beta, that one is plus 2 alpha beta. So, from here, if I want to get this value, alpha square plus beta square, by the time I take this guy to the other side, I have alpha plus beta all squared minus 2 alpha beta, which is now equals to alpha square plus beta square. What we are trying to use here. So we can just put this one at the corner in our note and we can use it to prove all other form of this. Now, answering this question now, so what we needed to do here is to substitute these values. Our sum of roots alpha plus beta is given as minus 3 over 2 in this case. So we have minus 3 over 2 square minus 2 multiplied by alpha beta, which is 2 multiplied by 2. So the rest is just arithmetic. We can so that gives us minus, that will be 9 over 4 minus 4. That will be minus 7 over 4. And now, the next one is 1 all over alpha plus 1 all over beta. Number 2, we have the LCM will be alpha beta, alpha here, beta by 1. Plus beta here by 1, we have alpha. Therefore, we have alpha plus beta. We can rearrange that one to have this. And all we needed to do now is also substitute their values. And their values, which is alpha plus beta minus 3 over 2, all of this divided by alpha beta 2. So this will be minus 3 over 2 multiplied by half. And we have minus 3 over 4. And for the last part now, alpha, this will be 1 by alpha. One by 1, we have 1. 1 by beta, we have beta. Alpha by 1, we have alpha. And now alpha by beta, we have alpha beta. Therefore, we have 1 plus alpha plus beta, which is the sum of roots, plus alpha beta, which is product of roots. So we have 1 plus, what is our sum of roots? That one is minus 3 over 2 plus 2. So we have 1 minus 3 over 2 plus 2. This will be 3. 3 minus 3 over 2. We have answered by so doing, we have answered question 2, you see. So we take question 3 now. From here, I can also see about 3 questions that I have here. One, in question 3 here, I have salts is being tested and discriminant, which is also part of a quadratic. And in question 3 here, I have partial fraction and salts also. So I'll just take the 3 of them. Okay, we don't know which one will be coming, but it is always within that range. So we'll take the question involving salts here, and the question involving, here I have find all the possible square roots of 6 plus 4 root 2. That one is testing salts. The question A2 there, say find the possible solutions of the quadratic equation. I think I'll take that one first because we just finished question 2 that involves quadratic. So I'll take that one. This one says find the possible values of the constant. Find the possible values of the constant n for which for which x squared minus 4x plus 1 equals to n multiplied by x minus 4 has equal roots. Solution now. This one is testing two things: nature of quadratic equation and also the discriminant. And we use the discriminant to discuss the nature of a quadratic equation. Now, here we want to put this in the form of quadratic equation. The general form of quadratic equation: x squared minus 4x plus 1 equals to m. Let me open this at once. Minus 4m. And from here now, we can collect like terms, and we have x squared minus 4x minus mx plus 1 plus 4m. Plus 4m. And from here, everything equals to 0. And from here, I can factor my x here to have x squared minus 4 plus mx plus 1 plus 4m equals to 0. You know, by the time I compare this with the standard quadratic equation, ax squared plus bx plus c equals to 0, we discover that our a is equals to 1, b equals to minus 4 plus m, and c is equals to 1 plus 4m. Okay, so we want to substitute this one into our discriminant d, because it is when our d, which is equals to b squared minus 4ac, we got that one from the quadratic formula, the one we just proved in question 2. When this one is equals to 0, that is when we have equal roots. Therefore, our b squared now, b squared minus 4ac now is equals to minus 4 plus m square minus 4 times 1 times, what is our c, times 1 plus 4n. So this will give us, of course, the square will negate this minus, and we now have 4 multiplying 4, we have 16. 4 by m, that will be 4m plus 4m, that will be 8m. 8m plus m by m, which will now be m squared, minus this one, 4 by 1, we have 4. 4 by 1, I have 4. 4 by 4m, now I have minus 16m. All of this equals to 0. Okay, and now we have we can now rewrite this, we can rearrange. We have m squared plus 8m. 8m minus 16m, that is minus 8m. Now 16 minus 4, I have 12 plus 12 equals to 0. So 2 factors of 8, that when we add, we have minus 8, and when we multiply, we have 12. That will be m squared minus 2m minus 6m plus 12 equals to 0. And now I have, if we factor m here, we are left with m minus 2 here. By the time we factor minus 6 here, we are left with m minus 2 also here. All of this equals to 0. And now we see that, I think I can remove this one now. So we have m minus 2 common, we can factor that, and we are left with m minus 6. equals to 0. So m minus 2 is equals to 0, or m minus 6 is a 0. Therefore, m is 2 or 6. These are the possible values of m, constant m, that we can get from that equation. And now the second part of that question says, which is the A1 now. Find all the positive square roots of 6. We should be able to remove this one now, so that we can have the whole area. For the next question. The next question is that we should find all the positive square roots of 6 plus 4 root 2. 6 plus 4 root 2. 6 plus 4 root 2. So if I want to find the square root of this, I will assume a solution root x plus root y. We have explained this in one of our slides, in one of our videos in the past, where we generalize this, and we also equally solve example. So now, here, I want to find the roots here. So what I will do is, I have to be taking care of all these radicals, one by one. This is the possible solution that I can have. I want to get the values of x and y. Now, if I take, squaring both sides of, let me call this one equation star. Squaring both sides of star, we obtain 6 plus 4 root 2 equals to, if I square this one now, I have x plus y plus 2 root xy. Because this one implied that I multiply this one by itself. So x by x by root x will be giving me this. Y by root y will give this. And this one multiplying y and this one multiplying x will give us 2 of this. And now, from here, I can call this one equation 1. Okay. So, by comparing both sides of equation 1, we equally obtain the following. We now have x plus y equals to 6, and 2 root xy equals to 4 root 2. I can call this one equation 2. We name this one equation 3. But we can see that in equation 3, we still have the roots there, and it will be affecting our operation. So we want to deal with that as well. What do we do next? We square both sides again. Squaring both sides of equation 3 again, we now have, if we square this, that means 2 squared over 4. This one squared, that means xy equals to, if I square this one as well, this will be 16. If I square this, I have 2 times 2. Therefore, this will be 4xy equals to 32. Name this guy equation 4. We can now solve equation 2 and 4 simultaneously to get the values of x and y. Okay, I think I can still manage this side. So we now have from equation 2, we have x equals to 6 minus y. And this is, I can call this one 5. Name this one 5. By substituting equation 5 into equation 4, equation 4 becomes, equation 4 becomes 4. Whenever we see x now, we put 6 minus y multiplied by y equals to 32. I should have reduced this guy here. So this will be xy equals to 8. And this one will now be 6 minus this will be 8. 6 by y, we have 6y minus y by y squared equals to 8. So that one gives us, I can remove this one now. So this looks quadratic already. Let's take all of them to the other side. I have y square minus 6y plus 8 equals to 0. So here, two factors of this, that will be, then when we multiply we have 8, when we add we have minus 6, that will be 4 and 2. So this is y square minus 2y minus 4y plus 8 equals to 0. So that we now have, if I factor y here, we are left with y minus 2. If I factor minus 4 here, we are left with y minus 2 as well, equals to 0. So y minus 2 is common, we factor that, multiply, we have left with y here and minus 4 here equals to 0. So y minus 2 is 0, or y minus 4 is 0. Therefore, y is 2 or 4. Okay, so we want to substitute this one back into equation 5. And now equation 5 yields, equation 5 becomes, 6 minus y. X equals to 6 minus y. When we want to substitute the values of our y now. When y is equals to 2, x is equals to 6 minus 2, which is 4. And when y is equals to 4, x is equals to 6 minus 4, which is 2. So therefore, if you choose x equals to 2, your y is 4. If you choose x equals to 4, your y is 2. Any which way, that will be our solution. And therefore, the square root of 6 plus 4 root 2, 6 plus 4 root 2 now is equals to root 2 plus 2, or 2 plus root 2. When x is 2, our y is 4, so root 4 will be 2. Okay, and when x is 4 and our y is 2, then that will be root 4, which will be 2 plus root 2. So this will be the required solution. And the other sort that was tested there, the last part of it, question 3b here, says rationalize 2 root 3. We want to take the final part of question 3 now. Before I now add the partial fraction. The partial fraction. (3b) rationalize 2 root 3 plus 3 root 2 divided by root 3 minus root 2. Root 3 minus root 2. Now to rationalize, this one means we should take the conjugate of the denominator, use the result to multiply both the numerator and the denominator. Okay? Solution. So we have 2 root 3 plus 3 root 2, all of this multiplied by the conjugate of the denominator, which is now root 3 plus root 2 over root 3 minus root 2 multiplied by root 3 plus root 2. So we expand this now. 2 root 3 multiplied by root 3, that will be 2 times 3. I believe you all get that. 2 multiplied by 3, because root 3 by root 3 will be 3. Plus 2 root 3 multiplied by root 2, that will be 2 root 6, that is 3 times 2. Plus 3 root 2 now by root this will be plus 3 root 6. And now this multiplied by this, that will be plus 3 times 2 also. Since root 2 by root 2 is 2, and we now have root 3 multiplied by root 3, we have 3. Root 3 multiplied by root 2, we have root 6. Minus 2 minus root 2 by root 3, we have minus root 6. And now root 2 multiplied by root 2, we have minus 2. Therefore, all of this will give us, this is 6 plus 6. That will be 12. I want to take that one at once. So, since this one is like common, it's like having 2x plus 3x. So we have 2 root 6 plus 6. That will be plus 5 root 6. All of this divided by, this is root 6 minus root 6. That will be 0. So 3 minus 2, 1. Our result is 12. Our result is 12 plus 5 root 6, which is the required answer. So for question 3 now, these are possible. Okay, one more question that I said in the following year, this was mixed. It was in another year, we have question 3 stating that resolve the following into partial fraction. So we have partial fraction and solves tested here. So even this same question as well in another year. So now you can see the importance of all of this. Let me take that of the partial fraction so that we can go to question 4. Question 3, 3a here. So resolve into partial fraction 11x plus 12 over 2x plus 3 multiplied by x plus 2 multiplied by x minus 3. We want to resolve this into partial fraction. What do we do in partial fraction? It is believed that everybody knows how to add two separate fractions together. But when we have a singular one, how do we separate them? That is what partial fraction is all about. No? So this one is a singular fraction. We want to put it in smaller units. This type, because we have linear factors in the denominator, to each linear factors in the denominator, we have a over 2x plus 3 plus b over x plus 2 plus c over x minus 3. Here we have, there's two ways we can look at this. Either we take the LCM, we compare with this, and we have 11x by what we have next here. Or we go straight and say a multiplied by this remaining 2, since that's what we're going to have when we take the LCM. So that we will not raise too many questions, let's take the LCM. 2x plus 3, x plus 2, x minus 3. This one here, we are left with these two. Multiplied by a, we have a into x plus 2, x minus 3 plus. This one here, we are left with these two. Multiplied by b, that will be b into 2x plus 3, x minus 3 plus c into the last, these two also. We have 2x plus 3, x plus 2. So if I compare this one with 11x plus 12 over 2x plus 3, we discover that this and this will go. And we are left with 11x plus 12. That one that is equivalent. I think this equivalent is equivalent to all of this now. We also have two approaches to this. We can take this one by one, set this to 0 so that we can have the values of b. Okay, set this to 0 so that we can have the values of a, and set this one to 0 so that we can have the value of c. Or we can open this bracket, we can expand this and begin to we reduce all of them into equations involving A, B, and C. Our target here is to get the values of A, B, and C. So here I want to take the first approach that I have described, which is to, if I set this one to 0 now, let's say set x plus 2 equal to 0. This implies that x is equals to minus 2. And if we substitute that one into this now, we have for x equals to minus 2 here, this will be 11 into minus 2 plus 12 equal to this one. If I put minus 2 here now, it will be 0. So everything here will be 0. So this will be a into minus 2 plus 2 minus 2 minus 3 plus b. So I will only stop here. 2 into minus 2 plus 3 minus 2 minus 3. Since this one is involving minus 2, so this will be 0. Since this one is also 0. So now this will be 11 by this. I have minus 22 plus 12 equals to, this will be minus 4 plus 3 minus 1 minus 1 minus 2 minus 3. That one is minus 5. Minus 5 by minus 1, I have 5. So this will be 5b. Since this one is a 0. So that we now have this one, we have minus 10 equals to 5b. And therefore, our b here is equals to minus half. Sorry, minus 2. But if I go side by 5, I have b equals to minus 2. So, also we have set this one to 0. We set x minus 3 to 0. We have x minus 3 here also. We set x minus 3 to 0. We have, okay, let me continue to use this side. Can it contain it? No. So I have to remove this. So set x minus 3 to 0. And this implies that we have x equals to 3. Therefore, this one now becomes 11 into 3 plus 12 equals to a. This will be 0 because 3 minus 3 here will be 0, so I will ignore this. This one 3 minus 3 will be 0, so I will ignore this one also. I will go straight to C. I now have C into 2 into 3 plus 3. 3 plus 2. 3 plus 2 here will be 5. This one is 6. 6 plus 3, that's 9. 9 times 5, that will be 45. So this will be 45c equals to, this is 33. 33 plus 12. 33, 3 plus 2, that's 5. This is also 45. Therefore, C is equals to 1. And now, the last one, we also set, the last one now, 2x plus 3 to 0. And this implies that we have x equals to minus 3 over 2. In that case, if we substitute that one in here, we have by the time I substitute that one in here, we have 11 into minus 3 over 2 plus 12 equals to a into my x now, which is minus 3 over 2 plus 2. All this multiplied by minus 3 over 2 minus 3. So if I put that one here, if I put minus 3 over 2 here, we have 2 into minus 3 over 2. This will go, so minus 3 plus 3 will be 0. So since this one will be 0, B will be 0, and C will be 0 as well. So we consider only this. Now we have This one we have minus 33 over 2 plus 12 equals to, this one will be 2 times 2, 4. 4 minus 3, that's 1 all over 2. This will be a into half multiplied by minus 6 minus 3, that will be minus 9. This one is minus 9 over 2. So this will be minus 9 over 2. Minus 9 over 2 equals to minus 9 over 4a. And that one will give us, therefore, a here will be minus 9 over 2 multiplied by minus 4 over 9. Okay. So the Bible side like this. So this will go further to have 2. Therefore, our a is equals to 2. So now our a is 2, b is minus 2, and c is 1. Minus 2, 2, oh, okay. Therefore, the question 11x plus 12 over 2x plus 3, x plus 2, x minus 3 is now equals to our a, 2 over 2x plus 3 minus 2 over x plus 2 plus 1 over x minus 3. That will be the required solution. So we are done with question 3.